Okay, today we're going to wrap up our topic of linear equations. What we're mainly going to be looking at today is going to be interpreting the graph of a function given a table, and then we're also going to be talking about verbal descriptions between graphs, and also going to be evaluating for a story problem here at the end here. All right, first off, we do have these four functions here. I do have a blank one at the end that I'm going to just leave blank. If you print out these notes or have copies of the notes, you will notice that key difference here. I added this -3 in right here where we don't have a value. Okay. So looking at this now, what we need to do here is we need to complete the tables that they give us for the given function. So we have x and 2x, we notice at the top of our table, where normally we have x and then y. Okay, but the same thing is going to be done here, even though we have 2x. What we need to do is we need to find the y coordinate for all of the desired x's that they have. So what we need to do is we need to plug in the 1 in for the function. So if I do that here for the first one, I'm going to get 2 times 1, which equals 2. If I do that for the second one here, 3, I'm going to get 2 times 3, 6. Do it for the third one, we're going to get 2 times 5, which equals 10. Do it for the last one, 2 times 7, it's going to give us 14. Okay. Now this was a little bit of an easier function. That's why we were able to do it on paper here. But also keep in mind we can do this on the Desmos Calculator. Okay, we can do this on the Desmos Calculator by creating a table, and where the top of the table on Desmos is going to say x1, y1, we would just change those to say x2 and 2x. Okay. If we do that on the Desmos Calculator, if we create a table where it would have these headings, if we put the x coordinates in, it's actually going to compute what our y values should be without us having to do any of this work. Now for this one, it was pretty easy because it was just 2 times x, but you'll take a look at these future equations that we're dealing with. The Desmos Calculator is going to help us when we do that. Okay? All right. So what we'll do here is we're looking at this one. Once again, we're going to be plugging our values in here. So plug in -1, we're going to get 5 minus -1 squared. Okay, 5 minus -1 squared, which will give us 5 minus 1, which is a 4. Okay, and we're going to repeat this process throughout the whole thing. So I can actually just go ahead and rewrite all this out here. Now, once again, if we want to, we can use the Desmos Calculator. And if you have any questions on that, make sure you come in and ask me about how to see how we can use Desmos on here. I might try to create a video later in the week that has some of the things we've been using Desmos for, so we can see how we go about solving those. Now here, if we keep evaluating, we get 5 minus 0 squared, that'll give us 5 minus 0, which is just 5. Then we have 5 minus 1 squared. 1 squared is 1. 5 minus 1 is 4. And then right here, we're going to get 5 minus 2 squared. 2 squared is 4, so we get 5 minus 4, which is 1. Okay. Once again, if we use Desmos, all we would have to do is have x for the first column, 5 minus x squared for the second column. We type in -1, 0, 1, and 2. It's going to automatically not only compute these values here, but also graph them on the coordinate grid. Now, where the Desmos Calculator is definitely going to be useful for us is one example like this. Even though we're going to be able to find these 3 values hopefully pretty easily, the hardest thing is going to do is what happens here with -3. Okay, so what we're going to do here is, once again, we're going to plug in -3. So we've got the absolute value of -3 minus 5. We have the absolute value of 0 minus 5. And the absolute value of 5 minus 5. We have to compute all those. Absolute value of -3 is 3. And then 3 minus 5 is a -2. The absolute value of 0 is 0. And 0 minus 5 is a -5. And down here, the absolute value of 5 is 5. And 5 minus 5 is 0. So the problem that we run into is right here where we don't have a value, okay? Now, if we were on a Desmos Calculator, we could just plug in the values that are between 0 and 5 until we find the one that's -3, okay? If we had to do that by hand, we would have to check 1, 2, 3, and 4, because those are all the values between 0 and 5, all right? So if I were to extend my table a little bit here, if I plugged in 1 to my function, I'd have the absolute value of 1 minus 5, which is going to end up giving us a -4. If I plugged in 2, I get the absolute value of 2 minus 5, which is going to then be just 2 minus 5, which is the -3, which there's our value that we were looking for. Okay, we don't even need to check the other two because this is the one that's going to end up working here. The number between 0 and 5 that equals -3. Okay. Now I know that off the top of my head that we don't have to work through the rest of these because this is a special function here, an absolute value. Because I know that there actually is another value that's going to equal -3 on this grid, but it's between 0 and -3. Okay, it's actually -2. If I would have plugged in -2, I still would have ended up with an answer of -3. But this 2 value here is a number between 0 and 5 that's going to end up outputting the answer of -3. Now, I left this one blank here at the end for you if you want to practice this one on the Desmos Calculator. Create an equation. You can go absolutely crazy with it. Have several x's in it, square roots, absolute values, squares, cubes, whatever you can think of, and watch how easy it is that once you plug it in, if you just type 3, 4, 5, and 6 in for the x's, it will compute every single y for you really easily. Okay. Now, I know it's going to be kind of hard to read these, so I'm going to try to see if I can zoom in as far as I can so you can read them. What we're trying to do here is we're going to determine the value of the following. Okay, we're trying to interpret the graph of a function. So this one says the graph shows the number of quilts that can be made from a given amount of material in yards. We want how many quilts can be made if Joan has 8 yards of material. Now, what we should hopefully notice here is we do have a linear graph, linear function. The x-axis represents the material, so how much material we have, compared to the quilts, how many quilts can be made. So since we're told that Joan has 8 yards of material, we need to start on the axis that is talking about material, which would be the x-axis right here, okay? Once again, keyword material, material. We got to match them up because we are going to start right here where x equals 8. Now, how we find out how many quilts can be made from this? We need to go from the desired value straight to our function there. Okay, we see how it hits the graph. Then we're going to go straight over to where this hits the other axis. Okay, now where it hits the other axis is right here at 5, and that tells us that we can make 5 quilts from 8 yards of material. Okay, now if we would have went to 8 on the other axis, we would have ended up, I believe, right over here at 13. Okay, so make sure we're dealing with the correct numbers here. Since we're talking about having 8 yards of material, go to where 8 yards of material exists, which is right here. Follow it straight to the graph, follow it straight over to the other axis. So let's take a look at the next one here. You can pause the video and try this one on your own if you want. Okay, this one says the graph shows the number of miles remaining to walk depends on the amount already walked. Okay? We want to determine how far has Billy already walked if he has 4 miles remaining. Once again, keyword there is remaining, because we have to look at the axis that talks about the remaining miles. Okay? We want to talk about the axis that has the remaining miles. So, if he has 4 miles remaining, we look at the remaining axis. The 4 miles remaining is right here. We do the same thing. We're going to go straight to our graph. So, and then we go straight down to the other axis. We end up at 8. Okay? What that means is that 8 miles, or he has already walked 8 miles. Okay, want to make sure we're able to read this graph here. Pretty easy when there are these functions. We can just straight start with the what we know, go straight to when we hit the graph, and then down or over to see what the desired other coordinate is for the given problem. Okay, I'll zoom out here because we do have a word problem to end this section of notes on. See if I can't focus that a little bit. Excuse me. All right, this one, analyzing a linear function. Carlos is recording the temperature outside his house. At 7 a.m., it was -5 degrees outside his house, and it increases 3 degrees every hour past the 7 a.m. We want to create an equation, graph, and determine the temperature at 4 p.m. Okay? What we're going to do for this one is equation and determine the temperature at 4 p.m. The graph, we can actually illustrate on the Desmos Calculator, okay? Which we obviously can do, especially when we write our equation in slope-intercept form. We can be able to graph it pretty easily as well. Now, a couple things here. We're going to have to write this function out. Now, we know that this function is going to have an x in it. But the question is, there's more stuff involved in this. Okay? We know that it's -5 when he starts, and we know that the temperature increases 3 degrees every hour. So whatever this ends up being, since this is how many hours past 7 a.m., this is going to need to be a multiple of 3, because if this was 1, then we would have to add 3 degrees to the temperature. If it was 2, we'd be adding 6 because we add 3 every time. Since we're dealing with multiples of 3, we're going to have 3x right there. Now to check to see if this is our equation or not, we can plug in 0. Now 0 represents 7 a.m., okay, because that's 0 hours past when we started. So if I plug in that, I end up with 3 times 0, but that gives me 0, okay? That would be stating, okay, at 7 a.m. we have a temperature of 0, but we're already told that at 7 a.m. we have a temperature of -5. So we got to figure out how can I make this be, or how can I make this right here be -5? Because when I get 3 times 0, I get 0. But if I subtract 5 from it, that's going to give us a temperature of -5, okay? So what we need to do to our overall equation here is have 3x minus 5. That way, if we plugged in 0 for the initial time here of 7 a.m., we're still going to end up with what degrees it was, which was -5, okay? Now, that's our equation. Now we need to determine the temperature at 4 p.m. And what we need to do next is we actually are going to need to determine how many hours is between these two times. So if we start at 7 and we count up, all right, we have 8, 9, 10, 11, 12. There's 5 hours so far. Then once again, we go from 12 to 1. So we go 1, 2, 3, 4. That's a total of 9 hours right there, okay? We have 9 hours we need to deal with. So when we plugged in 0, that was representing 7 a.m. Now we're going to plug in 9, which is going to represent 4 p.m. Which in case, instead of putting 3 times 0, we're going to have 3 times 9. We're going to subtract 5 from that. 3 times 9 is 27, and then once again, take 27 minus 5. That's going to give us 22 degrees for what the temperature should be at 4 p.m. Okay? Now, of course, this is depending, that temperature is a linear function. Normally, temperature does kind of differ from just a straight linear function because it's not going to continue increasing 3 degrees, you know, if I were to plug in like 40 hours, okay? Because that could be something completely different and a little obscure because we don't, obviously that's going to continue to be some temperature. Now, let's see, if we plugged in 40, we would end up at probably 115 degrees outside. So if the morning starts at -5 and the evening ends with 115 degrees, it's going to be a little intense weather change right there. So understand that this problem, even though it's a little unrealistic, it's just basically analyzing the time from 7 a.m. to 4 p.m. can be represented as a linear function. Now, at 4 p.m., we might actually start seeing a decrease in temperature to be realistic. But for the problem that we're dealing with here, when we're trying to create the equation, all right, we know that it increases 3 every time, so that's why we do the times 3. We know initially we had a degrees temperature of -5, that's where we got the -5. And then since 4 p.m. is 9 hours past the 7 a.m., that's why we plugged in the 9 to get to the 22. Okay? All right, once again, remember we were just evaluating functions here. This is a lot of stuff that we did in the first part of this section, but we also were looking at the tables, how we were creating those, and also not forgetting that using the Desmos Calculator is going to help us tremendously with this types of problems. All right, that does conclude this section of notes. Make sure you complete the assignments for this section. And as always, if you have any questions, send me an email.